a boom so loud it shook windows 30 kilometers away. A dark wall of ash and superheated gas racing down the mountain at hundreds of miles per hour. And underneath it all, a volcano that has now erupted multiple times in just weeks. This is Conlayan, and scientists aren't just watching it, they're alarmed. Because what's happening on this island in the central Philippines isn't a single eruption, it's a pattern, a pressure cycle. And every time it resets, it gets harder to predict what comes next. Stay with me, because this story is more dangerous than the headlines are telling you. Conlayan volcano rises 2,465 meters above the island of Negros in the central Philippines, the highest peak on the island and one of the most active volcanoes in the entire country. It's a massive andesitic stratovolcano covered with fissure-controlled pyroclastic cones and craters, many of which are filled by lakes. Eruptions recorded since 1866 have typically consisted of phreatic explosions of small to moderate size. But what's been happening since June 2024 is anything but typical. In September 2024, PHI-VLC, the Philippine Institute of Volcanology and Seismology, recorded the highest sulfur dioxide emissions from Canlaon since 2009, reaching 9,985 tons, prompting warnings that the volcano could be undergoing its first magmatic eruption since 1902. Read that again. Its first magmatic eruption since 1902. That means fresh magma, not just trapped steam, pushing up from deep inside the Earth. Scientists immediately took notice. What followed was not one explosion, it was a relentless series of them. On June 3, 2024, an explosive eruption from the summit vent spewed ash over parts of Bago, La Carlota, La Castellana, and Canlaon. About 57,563 people were affected, with 3,905 displaced, 2,680 houses damaged, and an estimated $3.07 million United States dollars in agricultural losses. Then, December 2024, a second major eruption. The eruption produced a large plume that rose 4,000 meters above the vent and drifted west-southwest, with pyroclastic flow moving down the south-southeastern side of the volcano. A shockwave was also heard. Ashfall reached Canlaon and 10 municipalities of Negros Occidental, affecting other islands such as Guimaras and Panay. Around 87,000 people were evacuated. A state of calamity was declared in 31 cities and municipalities. Then April 2025, then May 2025, then October 2025, and then 2026 began, and the volcano didn't slow down. In 2026, explosive eruptions were recorded on February 19th, February 26th, and March 15th, 3 eruptions in less than a month. Here's what has volcanologists genuinely concerned. It's not just the frequency, it's the asterisk mechanism. PHI-VOLCs revealed that the Canlaon edifice has been swelling or inflating at very low and fluctuating rates since 2022 due to magma intrusion at great depths beneath the volcano. Since 2022. The mountain has been building pressure for years. Electronic tilt and GPS data showed short-term inflation of the edifice beginning in late January 2026, preceding the explosive eruption in February. PHI-VOLCs explained that the blockage of already established volcanic gas pathways of a deep magma source, or closed-system degassing, and resulting pressurization and swelling of the edifice generated the moderately explosive eruption. In plain terms, the volcano is building up internal gas pressure, blocking its own vents, and then exploding when the pressure becomes too great to contain. And here's the alarming part. PHI-VOLCs confirmed that this has been a repeating eruption mechanism since the volcano's first moderately explosive activity in June, producing nearly similar seismic characteristics and volcanic hazards. It's a loop. Pressure builds, vents block, the mountain explodes, then it resets and starts again. Scientists don't know when or if that cycle escalates into something far more catastrophic. The most terrifying hazard from Canlaon isn't the ash. It's what scientists call pyroclastic density currents, or PDCs. These are superheated avalanches of gas, ash, and rock fragments traveling at speeds that can exceed 700 kilometers per hour. They incinerate everything in their path. There is no outrunning them. The February 19, 2026 eruption produced hazardous pyroclastic density currents of hot volcanic gas, ash, and fragmented rocks, which descended the upper slopes within 1 kilometer of the crater and reached at least 2 kilometers downslope on the southwest flank. The eruption also produced a shock wave heard as a booming sound and felt more than 30 kilometers away. A week later, on February 26th, incandescent ballistics, molten rock fragments, rained around the crater while pyroclastic density currents descended the eastern and southeastern upper slopes within 2 kilometers of the summit crater. And it wasn't just Konlayan. At nearly the same time, Mayon volcano unleashed what officials called a lava collapse pyroclastic density current, described as one of the most dangerous volcanic hazards during eruptions, with authorities warning that further hazardous activity, including explosive bursts and additional PDCs, was possible in the coming days or weeks. Two major volcanoes, simultaneous activity, different causes, but a nation on edge. Behind every bulletin and alert level number are real people whose lives have been turned upside down. More than 8,600 families, about 28,272 people from 34 barangays in Negros Occidental and Negros Oriental were displaced after the April 2025 eruption. On April 24th, President Bongbong Marcos created a national task force to oversee the government's response. Around 87,000 people had to be evacuated after the December 2024 eruption, with 46,900 of them living in La Castellana. A price freeze was imposed in Negros Occidental to curb predatory pricing and prevent the hoarding of goods. A tent city was established in Himamayalan to house displaced residents in the event of an escalation. Farmers lost their crops. Children lost their schools. Entire communities were forced to abandon homes they'd lived in for generations. And the volcano is still active today. PHIVOLCS is running constant monitoring, seismic sensors, ground deformation instruments, gas sensors, satellite imagery. They're watching for the warning signs of a larger eruption. A level 3 alert, out of a scale of 5, was maintained for months, with officials keeping a 6-kilometer danger zone off limits. But here's what makes this situation uniquely difficult to predict. Before several of these eruptions, the volcano showed decreasing activity, not increasing. Sulfur dioxide emissions dropped to an exceedingly low average of 174 tons per day immediately prior to the February 2026 eruption, compared to the long-term average of 2,823 tons per day since June 2024. The silence before the explosion, that's the part that keeps scientists up at night. Researchers from the UP NOAA Center used an ash dispersion model developed by the United States Geological Survey to simulate ash patterns and improve hazard models, early warning systems, and risk communication in the region. They're not just monitoring, they're learning, building better models, trying to stay one step ahead of a mountain that doesn't follow a predictable script.